Hey there! Welcome back to another Roots of Unity video. I am Humayra, and today we will be continuing our rational functions series. Today we will be starting off with a fairly simple function, and to solve this we will be using the rules that we learned in our previous videos. Now if we remember, rule 1 was to find the vertical asymptote, and for that we say that our denominator cannot be equals to 0. So what are the values of x for which our denominator is 0? You'll notice that if we put in x equals to minus 1 or x equals to minus 2, our denominator becomes 0. So we can say x equals to minus 1 and x equals to minus 2 are two of our vertical asymptotes. Now we have to find the horizontal asymptote. What do we do for that? So since we have the factorized forms in both the numerator and denominator, let's expand and apply our rule. So when we expand both the terms in our numerator denominator, we end up with this. Y equals to 2x squared minus 11x plus 15 by x squared plus 3x plus 2. Now all we have to do is divide the coefficient of x squared in the numerator by the coefficient of x squared in the denominator. So when we divide 2 by 1, we end up with 2. So y equals to 2 is our horizontal asymptote. Now for step 3, we have to find the turning points of this function. And for that, we take dy by dx as 0. And when we solve, we end up with the turning points 2.74, minus 7 into 10 to the power minus 3, and minus 1.44, minus 142. Now, I know this is a very big calculation, so what you can do is you can pause the video and take a look at it, and if you have any questions or queries, please comment them down below. So let's go ahead and sketch in our asymptotes. We end up with something like this. So we now have three portions. A part where x is less than minus 2, a part between minus 1 and minus 2, and a part where x is greater than minus 1. And when we put in values that are less than x minus 2, our y ends up looking something like this. And between minus 2 and minus 1, we have a turning point. And when we decrease the value of x from the turning point to x minus 2, and again increase it from the turning point to x minus 1, you'll see our value of y decreases and our curve ends up looking something like this. Now, for the next part, you'll see that this is where things get a little bit interesting. As you can see, that we have a horizontal asymptote at y equals to 2 and a vertical asymptote at x equals to minus 1. And one general thing, if you've noticed, is that for all the curves that we have previously drawn, our curves never crossed any of the asymptotes, which meant that if you put in any of those values of x or y into the equation of your function, your calculator would have displayed something like an error message or not possible. But try this. Take your calculator right now and put in y equals to 2 in your function and see what you get. You will get x equals to 11 by 17 and not any sort of error messages. And your curve, if you put in more and more values of x, will end up looking something like this. Now, why is that? Why is the curve crossing the asymptote? Let's go back and see what asymptotes meant in the first place. Now, vertical asymptotes show us the behavior of a function at that particular value of x. So, look at x equals to minus 2 asymptote. At x equals to minus 2, our value of y becomes 1 by 0, which is infinity. And you'll see that sure enough, as we keep on increasing the value of x from x less than minus 2 to minus 2, the value of y gets very, very large very quickly. What about the right side of the same asymptote? As we decrease the value of x from the turning point and get close to x equals to minus 2, our value of y decreases very quickly and obtains a very, very large negative number. So for both the sides, in one side, y approaches plus infinity, and another side, y approaches minus infinity. So the vertical asymptotes show us the behavior of the function at a particular value of x. Now, what about the horizontal asymptote? Our horizontal asymptote shows us the behavior of a function as x gets very large or very small. Look at this side. As we keep on decreasing the value of x from -2 to -infinity, the value of y slowly approaches 2. So in summary, asymptotes aren't lines that the curve doesn't touch. They just show us the behavior of the function at particular values of x and when x gets very large or very small. Now let's go ahead and solve this too. So rule 1, we find the vertical asymptote, denominator cannot be 0, and for what value is our denominator 0? For x equals to 0, our denominator becomes 0, so x equals to 0 is our vertical asymptote. Now how do we find the horizontal asymptote? Simply divide the coefficient of x squared in the numerator by the coefficient of x squared in the denominator. 1 by 1 gives us 1. So y equals to 1 is our horizontal asymptote. What do we do next? We find any possible turning points. So we take dy by dx as 0, and when we solve, we end up with only one turning point, -2, 1 by 4. And then we find out any points where the curve might cross the horizontal asymptote, and when we take y equals to 1 and solve, we get x equals to -1. So at x equals to -1, our curve cuts the horizontal asymptote. So we've sketched in our asymptotes, and all we have to do now is just put in values of x that are less than 0 and x that are greater than 0 and find out the trends in y. Now for values of x that are less than 0, we end up with this. We have a turning point at -2, 5 by 4, and the curve crosses the asymptote at x equals to -1. And now when we decrease the value from the turning point, our value of y decreases and gets very, very close to 1. And before the turning point, for values of x that are between -2 and 0, when we decrease the value from x -2 and towards 0, our value of y decreases and approaches -infinity. Now what happens for values of x that are greater than 0? We end up with something like this. As we keep on increasing the values of x, our value of y increases too, but then it slants off at y equals to 1. And there you go, we just sketched the curve. Thank you so much for watching. If you thought this was helpful, stay tuned for my next 2 more videos where we continue the rational function series and then end it. And if you have any queries or suggestions, please comment them down below. And may you achieve all your goals that you set out to achieve today. Have a great day.